Hello, in this video I want to kind of help you understand how the parts of a parabola relate through an example of graphing and where we list all the parts and pieces of the parabola. So the first thing we know is that the focus is at the ordered pair 3, 4. And the directrix is at the line x equals 2. Now I'm going to go ahead and plot these on the graph and then use the graph to kind of help me figure out all the other pieces of this parabola. So I need to establish an x-axis and a y-axis based on what I have here. Let's see. Looks like most of our graph is to the right of the y-axis, so I'll move my y-axis kind of to the left over here maybe. Let's call that the y-axis. And then the x-axis, the focus is up above the x-axis, so I'll lower my x-axis maybe down to here. Okay, now let's plot the focus at the order pair 3, 4, and I will assume that each tick mark here is 1 unit. So 1, 2, 3, and then 1, 2, 3, 4. This is my focus. And I will label that with an F. My directrix is at x equals 2, so that is this vertical line going through the x-axis at 2. And what I know from this is that my vertex is between the focus and the directrix. So my vertex is going to be exactly halfway between those two right here. So that's the ordered pair where x is 1, 2 and a half, and y is 1, 2, 3, 4. So 2.5 comma 4 is the vertex. Okay, and then from there what I can get is a couple things. I can tell that this parabola opens to the right. Because the focus is to the right of the vertex. I can also tell that P is half of a unit because P is the distance between the vertex and the focus. So P is 1/2. Which then tells me that my focal diameter, remember the focal diameter is always 4 times P, so it's 2. So that's how wide my parabola is. And remember, the focal diameter is measured through the focus. So I know that my parabola is 2 units wide measured through the focus. So that means I need to go 1 unit up and 1 unit down to see the width of that parabola being 2. So let me write that in here. So that's 2, which is my focal diameter. So I can graph the parabola now. Let's go ahead and do that before we do anything else. Wraps around the focus, passes through the vertex, and has the width that we've stated, the focal diameter. And last but not least, we can list the endpoints of the latus rectum, which are the points that I put here at the width of the parabola. Remember, that's the latus rectum that runs across the parabola through the focus. So the bottom endpoint is the ordered pair 1, 2, 3 is x. In fact, both of these points have an x value of 3, so I'll go ahead and write the other one as well. And the bottom point has a y value of 1, 2, 3. And the top one has a y value of 3, 4, 5. So 5. So those are the endpoints of the latus rectum. So these are all the parts of this parabola. All of this hinged on the fact that we had to know that the vertex is exactly between the focus and the directrix. And we know that because the curve passes through the vertex and wraps around the focus. And it points away from the directrix. Okay? And that's all there is to the relationship between all of these parts and pieces of a parabola.